In this test case example, we will be using a bank policy to demonstrate a common access control error called separation of duty. This error occurs when two or more rules cause competing interests among subjects, resources, or actions. For example, giving one subject too much privileges to the point that they could misuse the system. Let's say resource report A contains important financial information. Some individuals at the company are tasked with creating the document, and some individuals are tasked with approving that same document. As part of company policy, the person who creates the report should never be the one also approving it. They do this to ensure full integrity goes into the information within the report. A separation of duty error would be occurring if flawed policy logic resulted in individuals who can only create the document also being able to approve the document. There are many unfavorable situations that could result from a separation of duty error. For this example, it can mean maybe a disgruntled employee maliciously add incorrect information to the report, knowing they could also approve it without anyone else realizing. If we quickly glance at our setup of this example, we will notice we have several subject, resource, and action attributes, as well as 3 ABAC policies to demonstrate this separation of duty error. 2 of our ABAC policies, bank teller policy and loan officer policy, have rule combination algorithms as deny overrides. Bank teller policy has a policy enforcement algorithm of deny biased, and loan officer policy has an enforcement algorithm of permit biased. F manager policy has a rule combination algorithm and policy enforcement algorithm of permit overrides and permit biased respectively. Bank teller policy has 30 rules, loan officer policy has 23 rules, and F manager policy has 10 rules. Next, we will quickly look at the security requirement schema we will use for testing in this example. Separation of duty situations are fairly common. Because of this, Security Policy Tool actually includes a feature to where you can create security requirements specific for these exact scenarios. So if we look at our separation of duty schema, abbreviated as SOD or SOD, we will see we have 2 security requirements. One testing if loan officer 1 can approve customer 1 loan, and the other testing if loan officer 1 can create customer 1 loan. Similar to our example in the beginning of this video, let's assume that per company policy that loan officers should be able to create loans but should never be able to approve loans. Now we're going to run one single policy verification so that we can see how our loan officer policy responds to our separation of duty schema. We will click Model Verification, New SOD Verification, SOD 1, Loan Officer Policy, and click Add. We will see 2 verification results for our 2 security requirements contained in our SOD 1 schema. As you can see, our results are true and true, meaning that based on our policy, a separation of duty error is occurring. Loan Officer 1 can create and can approve Customer 1 loan. To understand why we have generated these true results, we can click on our verification results to see which policy rules are matched with our results. If we first look at the results testing if the loan officer can create the resource, we will see we do have specific rule defined for this situation. Let's now look at the verification result testing if the loan officer can approve the resource. If we look, we will see all match results say not applicable. This can only mean one thing. If all match results in our loan officer policy are not applicable to this security requirement, then that means we haven't provided any rules related to loan officer 1 approving customer 1 loan. If there are no rules defined, then why do we get a permit default decision for this scenario? Well, if we take a closer look at our loan officer policy and we take a look at the enforcement algorithm, we'll notice that it says permit biased. Hence, when there are no rules applicable to a security requirement, the verification results will by default generate a permit response. We can resolve this policy flaw 2 ways. We can go back and change our policy algorithm to deny bias, and then this will give us a deny result, or we can add a rule stating for this specific situation that the loan officer 1 should not be able to approve this resource. Let's do both. If we go back to the loan officer policy, right click, select Update Policy, then change this from Permit Biased to Deny Biased and click Update. Then our old separation of duty verification results will turn red, signaling that due to a change we made with our policies, our test results are no longer up to date. We will right-click and select Refresh Verification, and now looking at our test results, the intended scenario is now occurring. The loan officer is being permitted to create the resource, but is being denied to approve the resource. Now let's again change it back to permit biased, but now this time create a new rule to resolve the error. So we can right-click New ABAC Rule and add a rule that Loan Officer 1, Customer 1 Loan, approve, except this time select Deny and hit Add. Then we refresh our policy verification results. We will see again we have now resolved this separation of duty error. You can download this completed Bank Test Case 4 project file on the Security Policy Tool website. Thank you.